Good afternoon. I am Mr. Ish. Thank you for joining me for this video. This video here is very well suited for a 12th grade high school math student. We're looking here at the procedure for verifying a law of cosines to be true. And this here is just a single way. There are multiple ways of doing it. I'm showing you an interesting way, which will be an excellent exercise. What does verification mean? It means that you're proving a specific law to be true. You're not showing how it's derived. You're just showing that the theorem or the equation or whatever it is, that it is true in terms of the relationship that it presents. Very quickly, the law of cosines. If you have a triangle, A, B, C are the sides. Each side opposes a corresponding angle. C opposes this angle C. A opposes this angle A, and B opposes this angle B, and the angles are capitalized for any of these sides. Let be any sides. If we were focusing on this side, you know the law of cosines would be that specific side square is equal to the other two sides square, and then you do 2 times AB cosine C. This item you see here in terms of its side shows up here with regards to its angle, the cosine of it. And just another one right here, if you're looking at everything with regards to a squared, the side square is equal to now the other two side squares, c square plus b square minus 2cb cosine this angle A regards to the side you're looking here. So you see how the law of cosines is. We have to prove that these type of formulas are good. And remember, there's a third one where there's one with C, there's one with A, then there's one with B. I won't write that out, but you know what that is. We're showing you that in this video that these formula are actually true. How do we go about doing it? I'll show you. A single best way, in my opinion, is to use trigonometry and the concept of unit circle. If you pick a specific point over here, from the center you draw a radius, you know that's the R. Bring it down and draw a right triangle. You have an R, you have an X, you have a Y. Bring this out so you can see it well. You have a certain angle here, theta, you have a hypotenuse R, you have a Y, you have an X. Determine the dimensions of X and Y using trigonometry. Cosine theta is equal to adjacent over hypotenuse. Sine theta is equal to opposite over hypotenuse. Solve each of these in terms of X and Y. X is equal to, look at this top equation, R cosine theta. Y is equal to, look at the second equation and solve for it, R sine theta. Now take the same triangle and replace the dimensions you've just determined. X was equal to R cosine theta. Y was equal to R sine theta. You know this is a right triangle. We have over here representation of an angle, its corresponding side, another angle and its corresponding side, and a third angle. You know this will be 90 minus theta because these two are complementary angles, and its corresponding side. Take any of these or all of these and run them through the law of cosines and see if everything works out. Let me pick this right here and this over here. I'll do R square is equal to the other two sides square, R sine theta square, plus R cosine theta square minus the other two sides, you know what they are, R sine theta and R cosine theta, and then the cosine of the angle for which the side is being evaluated, and that angle right here happens to be 90 degrees, or we say pi over 2. Think about it. Imagine this right here is my C. C square is equal to A square plus B square minus 2AB cosine C. Cosine 90 is wonderful in that it zeroes out, but when it zeroes out, it zeroes everything out it's attached to. You end up here with only R square sine square theta and R square cosine square theta. From this expression, isolate the R square. You have sine square theta plus cosine square theta. You know by means of a trigonometric Pythagorean identity, sine square theta plus cosine square theta always equals 1. This right here is equal to 1. In essence, you're left with just R square is equal to R square, and it proves out to be true. So we've shown that the law of cosines is indeed true utilizing this angle and its opposing side. We can do a similar exercise with another angle and its opposing side, and the end result should always be the same, that everything is verifiable. Let's pick this side. The opposing angle will be this right over here. So we'll do R cosine theta and we'll square that, because it's always the side square is equal to the formula you see that you have everywhere else. And here it's going to be the other two sides. One side is r squared, the other side is r sine theta square, and then 2 times the sides r and then r sine theta, and then the opposing angle to that side you're evaluating. The cosine of that is what? That angle right there, 90 minus theta. And that right there is it. If this right here is a, I'm looking at a squared is equal to c squared plus b squared minus 2cb cosine a. And it's good. This right here is the law of cosines, except we have expressions falling into it in terms of our variables. Open everything up over here. You have r squared cosine squared theta is equal to r squared plus r squared sine squared theta minus cosine 90 minus theta by means of a cofunction identity is no different than sine theta. The sine of an angle is equal to cosine of its complement. The cosine of an angle is equal to sine of its complement. So you are in essence substituting that for here. You multiply these items, this item and all of this. When you multiply them, you have r and r. You have a 2r squared, you have a sine theta, you have a sine square theta. So everything is falling into place. Now combine the terms. You have a r squared cosine squared theta is equal to r squared. Here's a like term and here's a like term. You have a r squared sine squared theta and minus 2r squared, and you get a minus r squared sine squared theta. It's no different than you looking here at a 1 minus 2, you get a minus 1, except this minus 1 is attached with this r squared sine squared theta. So it's everything is good over here. Take this on the other side. You have a r squared cosine squared theta plus r squared sine squared theta is equal to r squared. Now you're exactly where we were in the previous example that I was showing you. The trigonometric identity will eliminate that. You'll just be left with r squared is equal to r squared. From here you will have isolated, as you know, r squared into cosine squared theta plus sine squared theta, and you know that's exactly this, because this substitutes here for 1. R squared is equal to r squared, and it's done. I won't do the exact same exercise now utilizing this and its corresponding angle. You can do that on your own. I showed you with r and this angle, then I showed you with this side and that angle, and exactly the same procedure will be for this side and its angle. You'll run it through, and exactly what you've seen here with regards to the law of cosines, utilizing this approach, it makes the law of cosines verifiable and it shows it to be true. Remember, the general formula is c squared is equal to a squared plus b squared minus 2ab cosine c. That right there is your law of cosines, but these things can be expressed in terms of a squared and it can be expressed in terms of b squared, and everything else will follow. So in this video I've shown you that the law of cosines, this theorem over here, which is very beneficial for determining sides and angles of a triangle, any type of triangle, it happens to be true and it is verifiable. Thank you for watching this video. Have a nice day.